Fifth graders, how's it going? All right, so I have a dilemma. All right, I was cooling down. I had a cup of water and I was cooling it down, and I put it in the freezer because I wanted to really shock it and get it as cold as fast as possible. But now I have a cup of water that is just too cold. I'm going to go ahead and show you. I have a little thermometer in it, and you can see that the temperature is close to about 42 degrees. All right, that's too cold. All right, now what I want to do is I want to warm up this cup of water because I want to drink it, right? I want to drink a nice glass of warmer water, but 42 degrees, too cold for me. I like a little warmer room temperature water. Okay, so I do have this cup of hot water, but as you can see, it's purple. And I don't really feel, I don't know about you, but I don't feel like drinking purple water. That just doesn't really suit me. I like my water to be clear. I like it to be transparent. So I'm baffled because if I pour this water into, if I pour the warm water into the cold water, I know it will warm and make this water, the temperature rise. But like I said, I don't want to drink purple water. No. So what could I do to get this water, the temperature in this water to be warm? I'm looking for maybe about 50, 55 to 60 degrees. What can I do without pouring this purple water into it? Now think about it. I have 2 containers that might be of use. What do you think I could do with these 2 containers? Okay, so what I'm going to do, what I'm thinking is, because I don't want to contaminate the water and make it purple, what I'm going to do is I'm going to pour this hot water right in here. Oh, look at that, condensation's already forming on the inside. All right, here we go. Well, hot water in there. I'm going to move this out of the way. And what I'm thinking I'm going to do is take the thermometer out. I'm going to pour some of this cold water into this vial. Alright. So I'm going to put the temperature, the thermometer in here. And we're sitting at about 48 degrees. And what I'm going to do is I'm going to place this vial into this cup of hot water. Now make predictions. What do you think is going to happen? What is going to happen once I place this vial where the water is about 48 degrees into this cup of warm water? All right, let's go ahead and see. I'm placing it in. Can you see the thermometer? This may take a little bit. I'm going to have to get into focus, but what do you see is happening to the red line? We started at 48 degrees. There's a little condensation coming up. Gonna wipe it off. Oh, remember we were at 48 degrees. This water is almost to the temperature where I like it. We're at 60 degrees. Let's go up to 70 degrees. 70 degrees is about room temperature. What is happening? Remember the thermometer is in this container. All right, let me go ahead and drink some of this. Perfect room temperature water. But what happened? That was crazy. That was wild because this vial of water was in here. The water, though, remember there was water. I'm going to pour more water in here. The water in this vial was not directly in this cup of warm water. There was a plastic container around this cooler water. But why is it, though, that the temperature of this water was increasing when it was inside here? The 2 waters weren't touching. Oh, we're we're going to talk about energy transfer, my friends. Energy transfer. What is energy transfer? We got to look at it from this angle, all right? So when a hot material, let's just talk about, this is our hot water. When a hot material with lots of particle motion comes into contact with a colder material that has less particle motion, there is energy transfer. Now I know I'm saying a lot of things like particle motion, I'm going to talk about that, right? But we're seeing energy transfer. So pretty much when the hot and cold materials, right, come into contact, energy is transferred from one object to another. All right, so basically through energy transfer, the warm water, which was in contact with this glass, was transferring energy to it, which was then heating up the cooler water inside this vial. All right. Now there's a name for this type of energy transfer. It's called, any of you know, what is this type of energy transfer called? It's called conduction, all right, which is the transfer of energy or heat through contact. So in order for conduction to happen, objects need to be in contact or touching one another. That's the only way that conduction happens. Okay, so when I was explaining what energy transfer was and how it was happening, I was talking about particle motion. All right, now, and I have a picture right here. Let's pull up this picture. Oh no! Almost fell. All right. Can you see this picture right here? All right, so pretty much you can see in the bottom, let's just focus on the green at the bottom, right? We have a colder liquid and a hot liquid, right? We have our liquid in the vial, the warm liquid in the larger container. Okay, so pretty much you see two types of particle motion. We know that water contains matter, right? It takes up space and it occupies room. So there are particles in the liquid. As you can see on the left-hand side, the colder liquid, the particles are closer together, right? They're not as spread out or moving as fast. Whereas on the right side where you have the hotter liquid, right? That was our purple liquid. The particles are more spread out. You can even see that in the solid particles above us. So pretty much what's happening is as the temperature increases, the particles will start to spread out and move faster, right? They're moving around more freely, all right? The particles in the colder liquid are more clumped together, and they're not as spread out. They're not moving as fast, all right? You kind of think about this. When you're really cold, you want to shiver. You're trying to keep your body heat. You're shivering, and you're staying really close. You can't really move because you're shivering. But as it warms up, right, you're feeling looser. Your muscles feel a little more loose. You feel more relaxed. You can do more activities, right? And it's the same idea, same concept with this. So the colder the liquid is, the more compact they're going to be. They're not going to be moving as fast. But as the temperature slowly increases and it gets warmer, they're going to spread out and move faster. All right? So that's what was happening with the vial and the container of warm liquid. Right? In the cold liquid, where it's about 40 degrees, the molecules and particles are really close together. But as I place the cold vial in the cup of warm water, right, conduction, energy transfer is happening. Now, all of these particles in the hot water, right, they're moving. They're inside here. They're moving really fast. They're zooming around and they're bumping. They're coming into contact with this colder water. And as they bump into the vial, their energy transfer is happening. So now the warm water is transferring its hot energy into the vial of cold water, which is then causing the particles in the vial to warm up and move faster. That's what is causing the temperature to increase. Okay? So let's think about another form of conduction, all right? I have an ice cube right here. Now, what do you think is going to happen when I place it in my hand? What do you predict? What will happen when I place this ice cube in my hand? Here's a hint. Two things will happen. All right, let's see. Oh, I'm already dripping. What's happening? How did that already happen? I just put it in my hand. Oh my goodness. Can you see it? Let's see. Oh, it is raining in my house. Don't tell my wife. All right, what's happening? What is this process called? Did anyone say conduction? Where is there energy transfer happening? Remember, conduction happens when energy transfer happens through contact. That is conduction. So, as you can see in this lovely ice cube that is getting smaller and smaller, right? My hand, my body is warmer than the ice cube. So, the particles in this ice cube are really compact. They're frozen, they're stiff, right? As it touches and I squeeze my hand, the heat in my body transfers energy through contact to the ice cube, causing it to heat up and melt. Basically causing it to go from a solid to a liquid. But at the same time, my hand is starting to go numb. It's starting to get colder. And that's also due to conduction. Because the coldness, remember, temperature is basically heat, how hot or cold the temperature is, right? So this ice cube is cold. It still has heat, it's just much colder. The heat or coldness from this ice cube is in contact with my hand, right? So it's transferring energy or cold temperature to my hand, causing my hand to feel cold. All right, so there's two types of conduction happening here, where I'm transferring energy or heat from my hand to the ice cube, causing the particles to speed up and melt and move faster. But at the same time, the ice cube is transferring its cold heat or temperature to my hands, causing my hand to feel cold. So there's two points. There's two types of energy transfer happening with the ice cube. All right, boys and girls, I hope this makes sense. We're going to continue discussing in class, but let's continue this.